Welcome back, Patriots. Time to start semester 2 of Algebra 2, and we're going to start off reviewing stuff that you already learned back in Algebra 1. Nothing really new today, just going to be reviewing all of your exponent rules. Now, I want to go ahead and point this out before we get started. If you'll notice, the way this is going to work is I've got my screen set up so that I've got a left page and a right page, and it looks a little bit kind of wonky on mine. If you look at the papers you have, they actually don't match up. The reason for that, let me turn on my camera here, is because your papers that you printed off are going to look like this, with this over here on the right. And then when you flip it over, it looks like parts of a power like that. And so what I want you to do, if you got them out of order when you printed it, put them in this order. Put books of exponent rules on top. Then we've got this one with the examples on the left, and then 2 to the first equals 2. That's going to be page 2, facing this direction. Then adding and subtracting polynomials, that goes there last. And if you should have double-sided them. If not, good luck. You can match all that up. Going this way, we should have negative exponents. And then remember, you may exponent rules with, and then you got parts of a power. Anyway, put those all together like that, fold it over this way, and you've got yourself a nice little booklet. What we've done for the ones that are handed out in class is they're stapled right there, and then that's our notes packet for today. So what you'll notice is, like whenever I flip over to this particular page, which is what I've got displayed on the screen right there, now they all line up, and what you see on mine is going to match what you see on yours when it's done that way. So that's how you should set it up to begin with. All right. So we're covering all of our exponent rules. Now, what we're going to do first on our parts of a power, here's what you need to know. The entire thing is what we call the power. That's everything together. This part down here is called the base, and this one up here is the exponent. So whenever we talk about a power, it's a combination of both a base and an exponent. Now, the exponent is going to tell us how many times, stop that, the base is multiplied together. So 2 to the first power is just 2, because it's just, 2 times nothing. It's just 2. Okay. If a constant or variable does not have a written exponent, you automatically write that exponent as 1. So this here has an understood 1 on both of those. So if I was to expand this out, that would end up being x to the first is just x. Then it would be y twice, and then 1z. So x times y times z, which we write as just x, y squared, z. Okay, now, remember, you may only use all of these exponent rules whenever you have like bases, okay? So if I have bases that are different, like for example, I could not combine together this x and this y because they have different bases. Now, our little chart here for how our exponent rules work. So a power to a power, you're going to multiply the exponents. So for example, if I had x squared cubed, that is x to the 2 times 3, the exponents get multiplied together, which is x to the 6th power. Now, the reason that works is because you've got x squared cubed is x squared times x squared times x squared. Now, each of those x squareds is actually x times x, x times x, x times x, which is x to the 6th power. Okay, now when I multiply things together, I am going to add the exponents. Okay, now again, remember, you have to have the same base in order for this to work out. So let's say we had x squared times x cubed. Well, that's going to equal x to the 2 plus 3, which is x to the fifth. Again, the reason that happens, x squared is x times x times x times x times x, which is x to the fifth power, because I've got 5 x's there. Okay, now when I add or subtract, this only happens with like terms. Let's say that I had an x squared plus x cubed. Well, that's not like terms, so you can't do anything with that. Same thing with x to the fourth minus x squared. Nothing happens because the exponents are different. You cannot combine those at all. Now, if I had, when I say like terms, have the same base and the same exponent. So now if I had 5x cubed minus 2x cubed, now I've got the same base and power on both of them, so I can combine like terms and get 3x squared. Same idea with x to the fourth plus 7x to the fourth. Again, like term means I can combine them. That gives me 8x to the fourth. Okay, one phrase that kind of helps students out sometimes is multiply the bigs, add the littles. And when I say that, the bigs are the ones up here on top, the littles are the ones down here on bottom. Okay, so when dividing powers with like bases, treat the division bar like a giant subtraction sign. Okay, so here's what's going on with these. I'm going to write it out and all the way. So x to the ninth, we got 9 x's on top. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All of that over x cubed. 1, 2, 3. So what's going to happen is each of these x's is a like term. Or I'm sorry, I got an x on both on top and on bottom. And so those are going to end up dividing out. And what we're left with is all of these x's. We're left with 6 or x to the sixth on top over 1, which is just x to the sixth. Okay, that's why we're subtracting the exponents, is because we're getting rid of all of these things. And so it ends up just being 9 minus 3, which is 6. Okay, on this y example over here, we've got y's on top and on bottom. 2 on top, 2, 3, 4, 5 on bottom. And again, these cancel, leaving me with 1 over y to the third power. Now, kind of the funny, silly example we give on this is there's a war going on between the top and the bottom of the fraction, and the side with the most variables survives. So over here, we've got 9 soldiers on top, 3 soldiers on bottom, and so the top is going to win the war, but 9 minus 3 gives me 6, goes on top. Over here on this war, we've got our 2 and our 5. The 5 is going to win because there's more of them, and 5 minus 2 is 3. So the side with the most is going to win the war. All right, moving on with our negative exponents. Okay, to turn a negative exponent into a positive exponent, you are going to move it to the other side of the fraction. And in our war between the top and the bottom, negative exponents are the traitors. Put them on the other side where they belong with the other enemies. All right, so right here, we're going to simplify this down. And so x is got a negative 2 exponent. He is a traitor, so he's going to go to the other side. Then he becomes positive because he's not a traitor over here. Now we're going to put y on the other side as well because of that negative 3. So we just got y cubed over x squared. Now on this particular fraction, x to the fourth has a positive exponent, so we leave him alone. Now x to the negative 2 is the traitor. He's going to go to the other side. And there's nothing left over on bottom, and when there's nothing left over, we leave a 1. Now, that gets simplified down to just x to the 6th power. So there's my answer, x to the 6th. Okay, second's half of that page, okay? Anything to the power of 0 is equal to 1. Now, that means x to the 0 power is 1. Any large number, 4,611 to the 0 power is 1. Some complex, crazy thing. Well, actually, you know what? Let's do a simple one. 2 to the 0 power is 1. Some complex, crazy thing, x cubed y to the 9th z to the negative 47th all over q minus 3 pi to the 4th power all raised to the phi power. You don't even know what those symbols are. I mean, you know what pi is. You don't know what phi is. But all of that raised to the 0 power is 1. It doesn't matter. Just raised to the 0 power. It's always 1. Oh, I say anything there. I'm going to put that in quotation marks. Here's one exception. 0 to the 0 power is undefined. You can't do that one. There's a reason for that, but we're not going to get into it right now. It's one of those weird cases where it just doesn't work. If you try to put in a calculator, actually, let's try that and see what happens. Just for fun, let's do 85 to the 0 power is 1. 0 to the 0 power, crap. It can't do it. So calculator can't handle it either. All right, next up, moving on to our next set of pages, adding and subtracting polynomials. Okay, so you're going to do it first. You're going to line up your like terms. And when I say line up, I mean we've got our like terms. We got a squareds first. We got ab's second. We got b's third. That just helps you to identify all your like terms. I'm going to do it by highlighting and circling and stuff on here. That's another easy way of taking care of it. If you're subtracting, make sure you distribute that subtraction sign or distribute the negative sign. You're going to combine your like terms and then write in order from or in descending order, which means big exponents come first and then little exponents come at the end. So let's go ahead and find our like terms. We've got 3a squared and 6a squared. Add those together because this is an addition problem, is just 9a squared. Then we've got negative 5ab and negative 2ab, and combine those and I get negative 7ab. Then I've got 4b and negative 6b. 4 plus negative 6 is negative 2b. Okay, now on the next one here, we've got a subtraction sign. So we've got to make sure that we distribute that out. So that's going to give me a negative 3x, a negative x, and a positive 1. Now, let's see, we've got x squared and x squared. Now, x squared minus 3x squared is negative 2x squared. Now we've got a negative 5x and a negative x, and that's going to be a negative 6x. And our final one is a 2 and a positive 1, comes out to a plus 3. All right, now multiplying polynomials. Key phrase here is distribute everything to everything. So when we do this, we're going to make sure we distribute the 9 to everything. The 9 goes to all of those. And the n gets multiplied with all of them as well. So let's do the n's first. n times 4n squared is 4n cubed. Then n times 7n is plus 7n squared. N times -1 is negative n. Now, -9 times 4 is minus 36n squared. -9 times 7n is negative 63n. And then -9 times -1 is positive 9. Okay, now we got to take care of like terms. Now this n cubed, there is not any others, so we've just got a 4n cubed. Now we've got a 7n squared and a negative 36n squared. And so 7 minus 36, that'll give me negative 29n squared. Now I've got, and I'm going to start running out of colors here. Let's do negative n and negative 63n is negative 64n. And then my last one here is just my 9, so plus 9. Once all my like terms are combined, then I am finished. Okay, now let's go ahead and distribute this guy out. So 3x squared times 2xy. 3 times 2 is 6. X squared times x is x cubed. And then the y comes along for the ride. Now we've got 3 times -3 is -9. X squared times x is x cubed. And then the y squared comes along for the ride. And now we're going to multiply it by the 4. 3 times 4 is positive 12. And then we've got the x squared there. Okay, moving right along. Now, we've covered all these different examples, and we've isolated all the individual skills. Okay, so we talked about what to do for each of the powers, what to do with our division symbols and our negatives and our zero power, and all of those different things. Now, the problem is we're not going to use those. They're not always going to be separated out. We've got to start using them all mixed together. So that's what the purpose of these type of examples are. And you're going to see stuff like this on the test and on the homework assignments as well. So let's go ahead and run through here and start using all of our different rules. Okay. The first thing I like to do is I like to go ahead and start combining things where possible. So I've got my 2 and my -4. 2 times -4 is -8. Now, for my a's, I've got an a cubed and an a squared. That means here I've got a. Here I've got a. That's a to the 5th. Now, for b's, I've got my b to the -2 and my b to the 4th. Again, I can just add those two and I get b squared. Now, realize what's actually going on there. And I'm just going to do the b's, b to the -2, b to the 4th. There's technically this hidden fraction bar that we're not writing down. And what really should happen there is that this b squared is the traitor. He goes down to the bottom. And then we're going to subtract him the 4 wins, and she's still got 2 on top. So either way, adding the -2 and the 4 to get 2, or moving the b down and then subtracting them, you're going to get the exact same answer. Our answer here is -8, a to the 5th, b squared. Okay, now when we've got multiple, or we got a power with multiple things on the inside, we've got to distribute this power out to all of them. So it's going to go against all 3. So we're going to have 6 cubed, and then g, we're going to multiply the powers. 5 times 3 is 15, and then h, -4 times 3 is -12. But because this is a negative exponent, he's going to go down below the fraction bar that we hadn't written until now, because we don't need to if there's not a denominator. So our actual answer here is going to be, now 6 cubed is 216. Grab your calculator if you don't have that memorized. g to the 15, and then h to the 12. Okay, now remember that this x has a 1 exponent. We're going to, coefficients get divided like normal. 12 divided by 2 is 6. Now we got the 4 and the 1. The 4 is larger, so the answer is going to be on top, and 4 minus 1 is 3. Between the y's, the 5 is larger, so the y's end up on bottom, and then 5 minus 2 is 3. So 6x cubed over y cubed. Okay, number 4 is our first word, or our first addition and subtraction problem. We're going to make sure that we distribute that negative sign out. So we're going to have negative 4a and positive 2. And now we're going to combine our like terms. 7a squared and negative 4a squared makes 3a squared. Now we've got a 6a is the only one of its kind, so plus 6a. And then negative 7 and positive 2 makes negative 5. All right, for this problem, we're going to make sure that we distribute these out. So we've got 2x times 3x squared is 6x to the third power. Then we're going to multiply it by the 8y squared. 2 times 8 is 16. X times x makes x squared. The y comes along for the ride. Then we're going to multiply it here. So then we've got 2 times 1 there makes 2, and then x and then y squared. There are nothing really to combine in that one. Okay, now let's make sure we're distributing the negative 5. Negative 5 times 3 is negative 15, and then x squared y. Now we're going to multiply it by the 8x. That makes negative 40. The x goes along for the ride, and then y times y is y squared. Now we're going to multiply the negative 5y times y squared. That gives me negative 5. Y times y squared is y cubed. All right, now we got to look for like terms. So 6x cubed. I'm not seeing any other 6x cubes, so we're just going to write it down. 16xy squared, x squared y. Well, I've got a 16x squared y here, and a negative 15x squared y here. Means I will just have a positive 1x squared y. Now, for this 2xy squared, here I've got a negative 40xy squared. So that gives me negative 38xy squared. And then my lone one on the end here is minus 5y cubed. Okay, 6 can be a little bit tricky, which is why we saved it till last. Okay, what we're going to do here is we're going to write it out 3 times. Okay, that means we're going to multiply 3 times. So we're going to get c minus 2, c minus 2, and c minus 2. Now we're going to distribute the first set. So c times c is c squared. C times negative 2 is negative 2c. Now we're going to distribute the negative 2. Negative 2 times c is negative 2c. Negative 2 times negative 2 is plus 4. Now, all of that is just that first multiplication problem. We still have this last c minus 2 over here on the side. Now, let's go ahead and combine these two, and I'm going to have c squared minus 4c plus 4 times c minus 2. All right, now we get to distribute again. We're going to take the c squared times c is c cubed. Now times -2, and c times -2 is -2c squared. Now we're going to distribute the -4. -4 times c is -4c squared. And then times the -2 gives me +8c. Now we've got another one we've got to distribute. We've got to do this -4 times c, +4 times c, which gives me +4c. Then we're going to have to multiply it by the -2, which gives me -8. Now, when I look at my like terms, this one actually ended up pretty nice because I got my c squareds right here, and then I've got my c's here. So when I go to combine all these, the c cubed is just going to drop. -2c squared minus 4c squared is -6c squared. And then 8c plus 4c is 12c, and then the -8 is just going to drop. Okay, so now that I've gone through that, please do not take the bait. What students do on this, and I'm writing this whole thing in red here because it's wrong, people will take the 3 and try and just distribute it out. And it's c cubed minus, and they'll do 2 times 3, which is 6. That's wrong. Another thing students will do is they'll still get the c cubed, but then they'll realize that needs to be -2 cubed, and they'll get c cubed minus 8. That's still wrong. Okay, what you have to do, you have to do what we did in black here, we'll multiply it out 3 times, c minus 2 times c minus 2 times c minus 2, and then distribute those all the way through. So that's all I got for you today. Feel free to reach out to me if you need any help. I'm available online for tutorials every morning from 8 to about 8:30, 8:35 on Google Meet. So reach out if you need help. Let me know if you have any problems.